For almost half a century, Voyager 2 has been traveling through the endless darkness of deep space. Launched in 1977, it began as a mission to explore the outer planets, but over time, it evolved into something far greater. A lonely odyssey beyond the reach of sunlight, into the mysterious gulf between the stars. What started as an experiment in discovery has become one of humanity's most remarkable journeys, revealing truths and mysteries we never expected. A machine built for the impossible, Voyager 2 was designed during the early 1970s, at a time when space technology was still young. Its onboard memory was smaller than that of a digital watch, and it transmitted data using the power of a dim household light bulb. Yet, against all odds, it continues to function more than 46 years later, sending back faint signals, like whispers from a traveler in the void. Its long voyage was made possible by a rare planetary alignment, a once-in-centuries event that let it slingshot past Jupiter, Saturn, Uranus, and Neptune. By using the gravity of these giants as stepping stones, a method known as gravity assist, Voyager 2 gained the speed it needed to escape the solar system entirely. Crossing the final boundary. In 2018, Voyager 2 crossed the heliopause, the invisible border where the sun's influence ends and interstellar space begins. Scientists once imagined this edge as a clean line, like stepping from one room into another. But the spacecraft showed it was nothing like that. Instead of calm emptiness, it entered a turbulent storm, where the solar wind crashed against interstellar plasma in chaotic waves. Voyager 2 recorded strange bursts of radiation, unpredictable magnetic distortions, and sudden changes in charged particle flow. It was a discovery that rewrote our understanding of the solar system's edge, revealing it as a dynamic, violent frontier between two cosmic forces. A signal from the unknown, then came something even more mysterious. Recently, Voyager 2 transmitted a short, structured burst, lasting only 2.4 seconds, that didn't match any known system noise or background pattern. At first, it was dismissed as interference or a data glitch. But when the frequency repeated itself, exactly once, scientists began to wonder. Was it a new kind of cosmic phenomenon? Or could it be something else, something we're not yet equipped to explain? No evidence points to an artificial source, but the mere fact that this signal doesn't fit our models has left researchers puzzled. For now, it remains unsolved, a whisper from the deep that refuses to be ignored. Into the harsh beyond the heliopause lies a realm filled with cosmic rays and high-energy particles born from ancient supernovae. Without the sun's magnetic shield, Voyager 2 is exposed to the full fury of this invisible storm. For scientists, the data it sends is more than numbers, it's a map of what future explorers will one day face when humanity dares to follow. The readings show that space isn't empty at all. It's alive with magnetic pressure, radiation, and swirling plasma currents. Voyager 2 has shown that between the stars lies not silence, but energy, a constant hum of the universe. The golden record, our message to eternity bolted to the frame of Voyager 2, is a creation unlike anything else ever sent into space, the golden record. It's not just metal or music. It's a time capsule of everything we are, a portrait of Earth, crafted by human hands and hearts in the hope that someone, someday, might find it. The record carries 116 carefully chosen images, mathematics and molecular structures, human anatomy and DNA, mountains, trees, and oceans, the rise of cities, and the shapes of animals that share our world. It holds the patterns of our understanding and the fingerprints of our imagination. There are the sounds of nature, wind, thunder, rain, birdsong, and the simplest echoes of life itself. A laugh, a baby's cry, the beat of a human heart. And among them are greetings in 55 languages, ancient and modern, each one offering a single idea that unites them all: we exist. One voice, belonging to a child, says softly, "Hello from the children of planet Earth." It's a moment that bridges generations, cultures, and time, a child's voice reaching out into the cosmic ocean, perhaps still traveling somewhere across the stars. The record also carries music, an eternal playlist of humanity's creativity. There is Bach and Beethoven, alongside the shakuhachi flute of Japan, Peruvian folktunes, and songs from Africa recorded on dusty vinyl decades ago. Together they speak a language older than words, a language of emotion, rhythm, and harmony. This record is not meant to guide or teach. It is meant to speak, to say that life once bloomed on a small blue world orbiting an ordinary star. It is our message in a bottle, cast into a sea of infinity. Whether it is ever found is not the question, the act of sending it is what defines us. It is proof that curiosity and hope are universal human traits, that we wanted, above all, to be known. The Grand Tour of the Giants. Before it became an interstellar traveler, Voyager 2 performed something no spacecraft had ever done, the grand tour of our solar system's giants. At Jupiter, it captured sights no human had ever seen in such clarity: the roiling storms of the Great Red Spot, lightning arcing through its clouds, and the fiery volcanoes erupting from its moon Io, the first volcanic activity ever discovered beyond Earth. These were not lifeless worlds anymore, they were alive with power. Then came Saturn, where Voyager 2 revealed the breathtaking detail of its rings, billions of icy fragments forming patterns more delicate than lace. It flew past Titan, wrapped in a thick orange haze, hiding an atmosphere richer than expected, one that might, under different conditions, cradle life. It glimpsed Enceladus, smooth and bright, its surface cracked by mysterious heat that hinted at an ocean below. At Uranus, Voyager 2 found something no one had predicted: a planet tilted so far it rolls on its side, with a magnetic field twisted and offset, like a riddle in motion. It unveiled dark rings, icy moons, and a world painted in shades of blue-green, spinning in near silence. Then came Neptune, the farthest giant. Here, Voyager 2 discovered the fastest winds in the solar system, more than 2,000 kilometers per hour, and a colossal storm called the Great Dark Spot, swirling across its surface. On Neptune's moon Triton, it recorded geysers erupting nitrogen into space, proof that even the coldest worlds are not dead, but dynamic. Each encounter rewrote the textbooks. Each photograph transformed distant dots of light into worlds with stories. Voyager 2 did more than explore, it redefined how humanity sees its place in the cosmos. The fading signal now, decades later, Voyager 2 drifts far beyond the warmth of the Sun, over 19 billion kilometers from home. Its heartbeat is powered by a plutonium generator, a slow fire that grows weaker with every passing year. To preserve power, engineers have shut down most of its instruments, one after another, until only a few still whisper across the darkness. It takes over 18 hours for a single signal to travel from Earth to the spacecraft, and another 18 to come back. Each data packet that arrives is a fragile miracle, a faint echo carrying measurements of interstellar plasma, cosmic radiation, and magnetic fields. Information no other probe in human history has ever sent. But recently, something unusual happened. A short, precise burst of data appeared, lasting just over 2 seconds. It didn't match any known system error or background interference. Was it cosmic noise? A new kind of interstellar phenomenon? Or something beyond what we can yet comprehend? No one knows. And maybe that's the beauty of it. Even after all this time, Voyager 2 still surprises us, still reminds us how much of the universe remains hidden. A legacy that will outlive us all one day soon. The signal will fade completely. There will be no more data, no more status updates, no more whispers from the dark. Voyager 2 will go silent, a heartbeat finally stilled after half a century of flight. But silence does not mean death. It will continue to move, drifting quietly between the stars for millions, perhaps billions of years. By then, Earth will have changed beyond recognition, our continents reshaped, our languages forgotten, our civilizations replaced by new ones or gone entirely. And still, Voyager 2 will sail on, carrying with it a fragile record